Well, we're going to get straight into things this week. Welcome to Adventures in Astronomy. My name's Martin. One of the most common things that I see on astrophotography forums or astronomy forums is how much battery power do I need to power a rig such as this? There's a lot of confusion out there because you've got to get to grips with amps and watts and watt hours. If you're not an electrician like I'm not, and you're not used to dealing with sort of power requirements, this can be really confusing. And I see endless forum posts asking, will this battery power the equipment that I've got? One of the first questions we've got to ask ourselves when we're thinking about power requirements is, what have we got on our rig that needs powering? In a typical rig like this one, we've got a mount, we've got a focuser, we've got a camera and a filter wheel. We've got a guide camera. This one's got a flat panel. Not everybody has an automated flat panel. We've got some sort of computer, or you might have something like a Pegasus power box. In my case, I've chosen a PrimaLuceLab Eagle 6 Pro. It might be an ASIAIR, which takes a lot less power. And that's about it. We've got all of our gear that needs powering. So how much power do we need for a night of imaging? You might be asking yourself, will this 500 watt battery on Amazon cut it for a night of imaging? Or this 250 watt or 1000 watt? Now don't go away, because later in the video I'm going to be showing you the solution and the battery that I'm using and why I think it's a really good solution for this kind of setup. Little spoiler alert, it's way more power than what I need. In fact, I've probably got enough power for 2 nights of astro imaging, but I'd prefer to have too much than too little. And I think that's an important rule when you're working this out for yourself. Well, I'm not going to go too deep into the whole difference between amps and voltage and amp hours and things like that, because it can get confusing, but I'll do a few basics. Number one, you've got the voltage of the actual battery. Now, for almost all astrophotography equipment, you need a bare basis of 12 volts. Usually we power our gear at actually slightly over 12 volts. It's usually 12.5 volts, 12.7 volts, sometimes even as high as 13. Be careful, because you can burn your gear out once you start getting to 14 and 15 volts, and you have to check whether your gear can take that kind of voltage. But you might want to think as voltage as electrical pressure. In a typical astrophotography rig, you usually want 12.5 volts, 12.7 volts. The reason is, with a lot of batteries these days and with a lot of power draws, particularly my Eagle here, if the voltage falls below 12, if it's on 12 volts exactly and it drops down to something like 11.8 volts, the whole thing's going to shut down because it doesn't have enough electrical pressure to keep going. So you're really looking for a battery that will do just a little over that, 12.5 volts, 12.7 volts. The next thing to think about is your amps, which is to say the amount of current that your gear needs to be able to have flowing through it so it's got enough power. So if you take a focuser, that can have quite a short amount of amps. It might only be 1 amps, 2 amps at the absolute most. Some of these things barely take any amps at all. The guide camera being a good example of this, is going to be less than 1 amp, 0.5 amps at the most. And then finally, we've got watts, which is the amount of power being used. Now, all of these terms, amps, watts, voltage, they all sound slightly interchangeable, but they're not, and they're measuring different things. You'll find that the astrophotography gear that we've got on show, usually on the manufacturer's websites, they give the ampage, not the wattage, because it depends on the voltage coursing through it. So without making this explanation any more complicated than what it needs to be, you've basically got 12 volts times your amps will give you your wattage. So in other words, if we were to say that this focuser was working on 2 amps and it's drawing 12 volts in the electrical pressure, 12 volts times 2 amps, it's drawing 24 watts. Now, sometimes confusingly, we see AH, which is amp hours. and that can really confuse matters. So we might say that we've got a 10 amp battery with maybe 1 amp flowing through it, in which case it can run for 10 AH, 10 amp hours. But I think rather than thinking about amp hours, it's much more sensible to think about this as watt hours. How many watts do we need? And that's partly because all of the batteries are rated in watt hours. In the case of some batteries, you might see 500 watt hours or 1,000 watt hours. Now, in order to work out how much power that you actually need, we've talked about all the different components, and basically you just need to do a little table. I've got one on screen now that shows you a typical astrophotography rig and the ampage of each product, and then converted into watt hours just for 1 hour. Now, looking at the table, you can see it really is an absolute worst case scenario, because if you think about the things that are on the mount, we're not going to be slewing the mount all night. It's going to slew to its target, and then it's gently going to guide at that lower power consumption level. You think about maybe your cooled camera, and when it's cooling down, it's going to draw more power. But once it's settled at that, it's going to draw less power. If you think of the flat panel that's on this, you're only going to be using the flat panel at the beginning or the end of the evening. And so you can almost disregard that in terms of you're not going to need the power to keep that going for 10 hours. You might only have it running for 10 minutes or half an hour at the most. So your first job, if you're trying to work out battery consumption for your gear, is to basically do a table, much like this one, and to decide roughly what kind of power draw that you think that you need. When I did this exercise for my particular gear, I worked out that I needed roughly for a whole night about 500 watts. And that was based on about 10 hours, with the wattage being around about 40 watts per hour. 40 obviously times 10 gives you about 400. Little bit of a safety margin in case we got 12 hours of darkness. So definitely 500 watts should power this rig through a 10-hour evening. The one element that you do need to be just a little bit careful of is these things, dew bands, because they can be quite variable and they can draw more power sometimes than the computer, say, and the focuser combined. Sometimes these can draw as much as 4 amps. I tend to have the dew straps on quite low. You don't need them on at 100%. I've tended to find over many years of imaging that having them on 20, 30%, even if it's a really dewy night and humidity is 95% plus, 50% at the most is going to get you the power that you need to keep dew off the scope. Now, helpfully, in my setup, we are using the PrimaLuceLab Eagle 6. You've actually got a general idea on screen in the PrimaLuceLab software, roughly what the power draw is. But this isn't the whole picture. It's a decent guide. But you might notice on my astrophotography rig that the mount is actually being powered separately from the Eagle. And that's because this mount can take quite a large power draw, possibly more than the Eagle's capable of churning out. So I actually have the mount connected to the same battery, but with a different lead. So it's worth just bearing in mind that actually more accurate than the Eagle or any other kind of software like this, because I know Pegasus Astro has something similar, you're best off finding a battery with a screen where you can actually look at the power draw from the battery itself. Well, let's take a look at the solution that I've come across, which is a Bluetti Elite V2 100. You've got to decide for yourself whether you want to go with a bigger power pack, which is more money and more weight as well. This power pack's about 11.5 kilograms, or whether you want to go with something smaller and maybe only just get enough power in for 10 hours worth of imaging, but it would cut the weight down to, say, half of that weight at, say, 6 kilograms, and it would also cost less. Firstly, it's got a good cigarette lighter here, and I can just plug that into there, and it unusually has ports just below this that will take 2.5, I don't know if you can see this connector, but 2.5 millimeter jacks. So this actually powers my mount separately, making sure that I don't overload my Eagle. Along the front, you've usefully got some USB connectors, so you could possibly charge your phone if you needed to at the same time and you're in the field. But it's also got plug sockets there if you wanted to go AC route. I tend to just turn mine on. You'll see the fans just kicking in quietly. This power supply is pretty quiet in the main, and once I've hit the DC power jack, I can actually turn on my Eagle. You heard it beep there in the background, and it's ready to go. And I'm all good with the Eagle to turn that on. And you can see on the display that it's got 93% of power left. It's drawing 42 watts. Actually, it's fluctuating a fair bit there, 29, 15 watts. This is just while the Eagle is booting up. In a moment, we will turn on all of the power supply in the Eagle for all of the components, and we will see what that is drawing. Well, we're now in the Eagle interface, and you can see this little graph that we talked about earlier on. I can actually expand that graph, and it will show you the peaks and the troughs of the voltage and the amps and the watts all in one place, just to get an idea of how many watts all of this gear is actually pulling. So if I start by turning on the power ports, I'll turn on the focuser and the flat panel and the filter wheel and the camera. The mount is already connected, and as I said, that's connected to a different part of the battery, so it's not going through the Eagle. So this is not our true power draw at 40 watts. So let's now just load everything up into Nina. So I'll turn the camera on and the filter wheel on, do these one at a time for the sake of demonstration, and the focuser on and the mount on. I'm not going to turn the guider on. It's a tiny amount of power draw anyway, but the reason I'm not going to is it's going to start looking for PhD and we're not under dark skies. But if I turn the flat panel on, and I think that's about it. That's everything I've got. So if we go back to this and just let it settle down for a minute, you can see it's still only drawing around 30 watts. So plenty of power. So if I ran this for 10 hours, I only need a 300 watt battery. I've got more than enough power. You can see it sometimes going up to 40 though. So you need to be a little bit careful. And at the minute, it's not doing anything at all. If I were to, let's say, start cooling the camera down, and let's start opening the flat panel, and then I head back to the power draw, that power draw is going to increase a little bit. So that's actually gone down. There you go. You can start to see as these things start to power through that wattage is increasing. So roughly speaking, I need about 400 watts of power for 10 hours at night looking at this, if not a little bit more. So my 1000 is going to do 2 nights quite comfortably. However, it is worth just me showing you the actual power draw on the actual Bluetti, because don't forget the mount is not factored into this. So if we have a look at the actual battery performance now, you can see that it's hovering around about 50-55 watts. Occasionally it will just jump up to 75 watts or so, but that's only for a moment. So you've got to imagine having enough power to slew and for the camera and the focus are all to be working. So it's quite conceivable that this could be drawing 80 watts for microseconds, but certainly not through the night. On average, it's settling around 45-50 watts. I should say just before we come to a close this week that I can highly recommend, if you buy a Jackery or a Bluetti in roughly the size that I've got, this bag that I've bought is absolutely fantastic. I will put a link out onto the Amazon link for it, but it's really good. It protects things and you can sort of keep the lid closed while you've got things plugged into your port here. There's also quite a handy bit at the top that can be unzipped, and I can keep the power cables and the chargers in there. It's unlikely to overheat at night, but even if it did and you were on a particularly hot night, it's also got these helpful side pockets that you can Velcro to the top to give access to the battery and the fan components, so it will keep it cool. I've actually not needed to use that yet, but it just keeps it nice and dry, and if you're worried about dew, definitely worth a look. So I will post the link to that down in the comments section in the description below. Well, that's it for this week. I hope that was a really helpful run through, and that those of you, particularly if you're new to astrophotography and you're thinking about buying your first battery, you've now got a good idea of what you need for the night. In short, and you could probably summarize this video, a 500-watt battery is probably going to do you well. But if you really want to be on the safe side, you might want to aim for a 750-watt or even a 1,000-watt battery. Thanks for watching. I hope you've enjoyed this week. My name's Martin. You've been watching Adventures in Astronomy.